Couple of announcements here. The midterm, originally on the course outline, I had that scheduled for February 25th. That is during reading week. Obviously, I'm not going to have you do the midterm during reading week. My intention was to have it the week before reading week. So Friday, February 18th, that is actually the last Friday before reading week, is the accurate midterm day. So I apologize for any inconvenience on that. If there's somebody who has an issue, please let me know. I know once in a while people have scheduled things, doctor's appointments and things like that, that cannot be undone once they have their semester schedule. Like I said, if you have an issue with that, please do contact me. I'm not going to say anything more about the midterm at the moment. It's more than 2 weeks away. And once I've had a little bit more time to think about the format and all those kind of things, I will give you that information when I have it, and also to give you an idea of what it's going to cover and all those kind of things. So no more on that now until we're a little bit closer to the actual date. Another announcement is I got a message from Accessibility Services. They were asking if anybody would like to be a volunteer note taker for this class, and this was the information they sent me. They sent me this slide, and if this is something you would be interested in, if you already take good notes, then it's an easy $100, and it's this letter of recognition, which is great too. And anyway, that's the information. You can get the information from the slide. I posted it to Moodle with this with these PowerPoints. So anyway, that's it for that. Okay, so let's try to figure out where we left off last day. And I believe that this was where we left off. We were talking a little bit about carbohydrate digestion. And so if you go back a few slides, remember we were talking about, we started off in the mouth, and there's starch begins to be broken down in the mouth due to salivary amylase. And so it usually gets broken down into maltose and sometimes glucose. And so that's why things might get a little sweet if you chew them for a while. If you get a biscuit or a carrot or something like that, it starts to get a little sweeter after a little bit of chewing. And usually the amylase is deactivated in the acidity of the stomach. So the starch digestion stops there. And then we get to the intestine. And the intestine, any disaccharides such as sucrose or whatnot are broken down into monosaccharides. And those types of sugars are generally absorbed quite quickly. And more complex carbohydrates a little bit slower, right? And fibers, as we mentioned, are not really digested. Some might be fermented by bacteria. And again, the composition of your food is really important. If you are eating a really starchy meal, but there's a lot of fiber in there, the fiber is going to kind of protect the starch a little bit and digest it a little bit more slowly. And we're going to come into this concept in a few minutes when we're going to talk about the glycemic index. And you can imagine that, again, the starches between different plants can be a little different. Some are more branched, some are less branched. In terms of the biochemistry of what's going on, that can make kind of a difference or not. If you have protein and fat in that meal, all these things are going to affect the digestion of those carbohydrates. But generally, they're all broken down into monosaccharides, which get absorbed by the intestine and end up in the blood. And so we want to talk a lot about blood sugar here in a few minutes. But I think that's about where we left off, if I remember correctly. And so let's talk about a few things around that blood sugar and the glycemic index and things like that. Actually, maybe this is where I left off last day. Advice for reducing gas. So I won't say anything more about this, except that we are going to talk about this last one here right now, which is lactose intolerance. And this is something that a lot of people have to deal with. And so it's definitely worth talking about a little bit. So what is lactose intolerance? It's actually relatively simple. It has a lot to do with this enzyme here. It's called lactase. So lactase, by the way, if you ever see ASE on the end of something, it's usually an enzyme. In fact, I don't know any non-enzyme examples. So what does lactase do? It breaks down lactose, which is shown there in the picture. So it takes lactose and it breaks it down into the two components, which are glucose and galactose. And it's really that simple. And so what's going on here? We all make lactase when we're infants because most of us breastfeed or take formula. So you're drinking milk is kind of your only part of your diet as a baby. And so it's an essential enzyme for babies. In fact, it's found in all mammals when they're born. Most mammals, as they age, their body, I'm not exactly sure what the mechanism is, but we lose the ability to make lactase because presumably, well, most animals, once they get weaned, they're not consuming milk again. But humans, particularly some populations, we seem to have the ability to make lactase for all of our lives, which is great because it gives us a whole category of nutrients and a whole food group of dairy products that we can take advantage of. Dairy products are, of course, rich in protein and calcium and things like that. And so this is awesome. So if you can make the lactase, which is shown here on the right, then these sugars here, you can see the glucose and the galactose are getting absorbed by the blood and they're going through all the normal digestive process. You're getting the benefits of the protein and calcium and other ingredients in milk, and all is good, right? Those who are lactose intolerant, you can see over here on the right-hand side, there's no enzyme. So you're stuck with this lactose, okay? And the lactose basically starts to go down into the large intestine, and bacteria such as E. coli, they like to digest lactose, and there's other bacteria, and the problem is they start to produce these byproducts that can be unpleasant, right? So gases and acids, and which can lead to discomfort in like pain in the gut and gas and those kind of things. And so that's kind of obviously a big deal. Nobody wants that kind of thing. I think I've got a map here to kind of show you in terms of the human populations who is affected the most. So this is kind of looking at geographical origins, right? So if you look at the Canadian population, at least 16% of the population is lactose intolerant to some degree. Some estimates put it around 25%. But it seems that if you are, if your family origins are kind of from the Northern European area, you're really good at digesting lactose. The rest of Europe and Asia and Australia, not too bad. And then you can see these other parts of the world, it gets worse and worse, right? We're looking at, 60, 80% lactose intolerant kind of thing. And this has probably a lot to do with human history in terms of the types of foods these people were eating thousands of years ago. And so us as their ancestors have either benefited or not benefited from those, from the what's happened to the human populations, right? Now, one thing to say about lactose intolerance is that a lot of people overestimate their intolerance, right? And so, most people make some lactase, right? Is what I'm trying to say. And so most people that are lactose intolerant can actually tolerate some milk products. Kind of depends on what you're drinking. If you're drinking a giant glass of chocolate milk, you're probably in trouble. But certain types of cheeses aren't a big deal for some people. And particularly, for example, goat cheese is lower in lactose than, say, milk cheese, for example, and those kind of things. So often it's one of those things where, people have to figure out what works for them. Some people go all out and they're like, no dairy. Other people will eat the cheeses, but skip the ice cream and the milk and those kind of things. I think I've got a table here giving you an idea of how much lactose is found in different kinds of milk. And so you can see right at the top of the list here, cow's milk. Cow's milk here, you can see is pretty high in lactose. But, as you get down the list, right, you can see a lot of cheeses, cream cheeses, not as bad. I'm not familiar with all of these other cheeses. Telegio cheese, I don't know that one, but apparently zero lactose in it. And you can, of course, get products as well that are lactose free, right? There's all sorts of lactose-free dairy products. What they've done in these dairy products is they've actually put the enzyme in there during the milk bottling or I guess putting in cartons, right? And so that enzyme, just a tiny pinch of that enzyme is enough to basically digest all of the lactose in these products. And so, or another option is you can buy the enzyme directly, and that's what I'm showing here on the left is these lactase tablets, of which there's a few brands of it. So I think my sister does this. I think I heard her once talking about having to take these tablets or something like that. I'm not sure. I never really did ask her about it, but I know another person who does this as well. And I know another person who has basically gone completely dairy-free. They just say it's not worth it. And I'm not sure how much these products are, right? I don't usually buy the lactose-free ice cream. And I haven't really sampled a lot of the dairy alternative ice creams because, well, I've got my favorites. I love ice cream. And for me, it looks like I tolerate it quite well. See, there's a question here. Somebody says, am I going to provide a study guide for the midterm? That is the plan. So thank you for asking. But I do hope to do that and give you a bit of an idea of how to tackle it. So one thing to keep in mind is you'll notice that a lot of food guides and dietitian recommendations, there are some concerns about people who aren't drinking milk, particularly developing children and pregnant women, because you do need a lot of calcium. And that is, of course, essential for bones, right? And so there's all sorts of guides in terms of what kind of foods to eat and those kind of things in terms of you can get a lot of calcium, for example, from the dark green vegetables, right? That's one there. What was I going to say? There's calcium fortified foods. I've noticed the orange juice. That's one I was looking at in the grocery store, and soy milk. And if you're not completely vegan, maybe you'd eat sardines and you can actually get calcium from the bones, right? But there's a lot of products out there. Some of them I'm familiar with, some I'm not. You can see almonds, for example, tahini, apparently sweet potatoes. Anyway, lots of good products out there. It's something, like I said, more or less to watch in children, women who are pregnant, and women who are postmenopausal in terms of, they need a little bit more calcium than kind of your average person. Okay. So let's talk a little bit more about glucose and in terms of what it's needed for. Glucose, by the way, that's a model of glucose. That's actually in my office. I have a model of glucose, and I just have to say, it's kind of hard to appreciate a two-dimensional picture, but in some ways, it is really a very beautiful molecule. And if you ever want to drop by my office, and I can show that to you and tell you why it's so beautiful, I'd love to do so anytime. But something we had mentioned last day is that it is essential for the body, right? We need it for our brain and nervous system and our red blood cells. That is the only fuel that our brain can use and our red blood cells. So it's got to be in our diet, or we can make it, and I'll kind of get to that at some point here. I think I've got some notes on that coming up. And anyway, so it is very essential to have it. We don't have to consume direct glucose. Obviously, we can consume starch, which can get broken down into glucose, but it is very, very important. So just a tiny bit of, I guess we could say, biochemistry for you. You may remember some of these things from high school biology if you took it. Glucose can get broken down in a process called glycolysis. It eventually gets broken down further in another process called the citric acid cycle or the Krebs cycle. And really the point is that you're getting two things, right? You're getting energy. Oh, come on. Every time I touch the screen, it wants to mess me up. Energy, and then the byproduct is carbon dioxide, and that's what we exhale from the lungs. And in order to do so, we need oxygen and water to break this whole thing down. So that's kind of the point I want to make from that. Now, hold on. I'm getting ahead of myself. I feel like I'm missing something here. Let me just take a look at my notes. Trying to be organized. Yeah, so that's kind of the basics, right, of what we're doing. And this is what's going on in your brain, of course. Now, if you don't get enough glucose, what might happen? That's another question, right? And so if you don't get enough glucose, you might enter into something called ketosis. Now, I just need to take a look here. Okay, yeah, I'll get to that in a second. Now, you may have heard of ketosis because, of course, now there's the ketogenic diet is a big thing that lots of people are excited about. And I'll touch on that at a later lecture and a little bit today in a moment, but just want to kind of tell you what ketose is. Ketosis, sorry, is when you don't have enough glucose and your body switches over to basically burning down fats, right? Which is not a bad thing, right? And when you break down fats, you get something called ketones. So that's where the name ketosis comes from, right? So not a bad thing, okay? In fact, that might be your goal in life is to, burn a little bit of fat and lose some weight, and that's not a bad thing. And it's not always harmful, right? Kind of done at the right level, okay? But it can get harmful if you're just doing this all the time, right? And this is where it gets dangerous, and this is where the ketogenic diet, there's a lot of people that question, in terms of, how safe it is, particularly in the long run as well. But you can see there's a list here of some of the consequences of prolonged ketosis, right? So vitamin mineral deficiencies, altered blood lipids, all sorts of other things, right? And possibly, I believe there's some links with heart disease as well, and those kind of things. This ketogenic diet was initially developed for two people groups. You can see that at the bottom of the screen, it's mentioned here, children with certain types of seizures it was developed for. Now, I don't know a lot about seizures, but seizures, of course, have something to do with the brain. And so the therapeutic diets are trying to get to that level where there's, just a small amount of glucose at all times to power the brain, but not too much. And again, I don't entirely know what's going on with the children with seizures. Also, some diabetics have gone on this kind of thing. And this is where people start to realize, this is one way to lose weight. And so kind of enter the ketogenic diet or the keto diet. And so if you Google ketosis, you're going to get a whole bunch of infographics that look like this. And I'm not going to go into all of this because it would take me a long time to kind of get through. And there's a lot of chemistry involved in terms of what ketosis really is. But the warning, I have to say, is that a lot of the ketogenic diet websites do not have this completely accurate, okay, in terms of what ketosis is. You can see what they're trying to do is sell it as something where you're going to burn fats. And like I said, that is accurate. But I think there's a lot of questions around the research in terms of exactly how to do this properly for losing weight. And of course, the long-term effects are the big concerns because we don't fully understand this. Imagine this, reducing your carbohydrates. So in a lot of these ketogenic diets, people are not getting the fruits and vegetables and fiber that they need, which is essential to prevent heart disease and all sorts of other things, and very good for your diet. And there's different ways to do these keto diets as well, right? You can go and eat bacon all the time, and technically you're not getting carbohydrates in there, but that's not going to be healthy for you. Let me just say that. So I'll probably come back and talk about the keto diet later, but I'm just wanted to say that just be aware. Ketosis is something that is not accurately represented in a lot of these keto diet websites, right? They're making it sound like it's an easy fix, and it's not so simple. Maybe I'll say one more thing about these keto diets. Like a lot of diets, what they are doing is forcing people to cut out the junk, right? And honestly, that's kind of the number one thing a lot of these diets do. They restrict your diet, and suddenly people are not eating soda pop, they're not eating pie, cake, they're cutting out all this excess sugar, and suddenly their body is changing. No surprise there. Anyway, more on this at a later time. I feel like there's something else I was going to say about this, but maybe that's enough for now. Like I said, I don't want to get into all the technical details about this, other than to say ketosis is when the body is doing something different because it's not getting carbohydrates, so it's starting to burn more fats. Okay, so I want to talk a little bit about storing glucose and what happens when you eat a meal. So I was going to make a little kind of flow chart here in terms of what happens when we eat a meal, right? So here goes. So first thing is we eat, I'll just say eat sugar or eat meal. And then what happens next is your blood glucose rises. So I kind of want to just talk a little bit about that and some of the hormones involved. And you've probably heard of some of these hormones. But this is kind of number one, what happens when you eat a meal, and presuming that that meal has carbohydrates in it, right? Your blood glucose rises. And then what happens? So the pancreas gets stimulated. Pancreas releases insulin. So most people have heard of insulin. It's a hormone, it's a protein, and it is secreted by the pancreas. And it's the response of the body when suddenly you have a lot more glucose in the blood. And then a few things happen, right? So insulin basically is a hormone, and it tells cells, hey, take in some glucose. So here we go, cells take in glucose. And so what does this lead to? So your cells all over your body have a little bit of extra glucose. They have some energy, but there's two areas of the body that are maybe the most significant, because they're the two areas of the body that can take in the most amount of glucose. One is the liver. So the liver can store glucose as glycogen. Remember, glycogen we talked about as the storage state of glucose in the body. It's basically a bunch of glucoses tacked together. It's kind of similar to starch, but it's a little bit more branched. Unfortunately, the liver can do something else. So it can convert excess glucose to fat. So that's the part we don't like. Well, maybe depends on where you are. Maybe you're trying to gain weight. For kids, actually, this is good. Kids need fat because they're going to use that energy to grow and all that. And you're not eating all the time. That's the other thing. So in the short term, actually storing a little bit of fat is not a big deal. But in the long term, if you do consume too many calories, you are going to convert a lot of stuff to fat, and that will lead to weight gain, of course. The other tissue are your muscles. So muscles store the glucose as glycogen. Of course, suddenly I can't spell. Let's try that again. Glycogen. So it's pretty straightforward, right? That's what you do. You eat glucose, your cells take in a little bit, and then the rest either gets stored in the liver or the muscles, or might get converted to fat, and which would be stored in, of course, fat tissues, right? So maybe the other half of this should be releasing glucose, we'll call it. So like I said, remember that your brain has to have glucose. And here's the thing, you're not eating all day long to make sure that your brain is getting glucose. So we have to be able to reverse this last step here, right? So that we can get some glucose to our brain, right? So we'll call this number 2. I guess I don't need the numbers, there's only 2 things. Numbering is not necessary. We'll say you have not eaten in a while. You have not eaten recently, we'll say. Okay, so then what's going to happen? Well, your blood glucose is going to drop. Once your cells start to take it in, and there's no more glucose coming from a meal, your blood glucose is going to drop. Okay, what happens next? Well, this stimulates your pancreas again. So pancreas releases a different hormone. And this hormone is called glucagon. So most people have taken a little bit of biology, have heard of insulin and maybe glucagon. And you can see they actually have the exact opposite effects. And the glucagon really just stimulates the liver. So the liver cells basically are going to break down the glycogen. Break down glycogen. Sorry if my handwriting is bad. I find a really hard time writing on these computer screens. And into glucose. And the glucose is, of course, released into the blood. So you can see what's going on here is we have a system for basically trying to maintain our blood glucose levels at a level that is good for our body, our brain, and our other cells, right? If it's too high, we can take away the glucose from the blood by secreting insulin. It gets stored in the liver or converted to fat, most of it anyway. If we don't have enough glucose for our brain, we can release it from the liver by secreting glucagon. So two hormones that you should know a little bit about. I feel there is something else I was going to say about this. Just so you have an idea, the liver stores, I think it's about 4 to 6 hours of excess glycogen, right? So generally, if you go longer than 4 to 6 hours without eating, that's where you're starting to have to get glucose from other sources. But usually most people are hungry enough by then. I don't think sleeping necessarily counts because your metabolism is slowed right down. Here's the image from the textbook that kind of just says everything that I just said. You can see they're showing the intestine and the pancreas and the liver and the muscle cells, and it's not bad. I just found it was a little bit overly complex, and so that's why I made my own little flow chart on it. But if you find this to be helpful as well, you can certainly take a look at that. There's no secrets around insulin and glucagon. We've understood their effects for quite a long time as humans, and in terms of what they do. So what else was I going to say about glucose? The other thing, and I feel like I forgot to put it in the notes somewhere, and maybe we'll talk about it in a later unit, is there's the question of what if you're not consuming any carbohydrates? Or what if you're starving? Or what if you're fasting or something like that? How do we get glucose for our brain? And that's a great question, right? So if you're fasting and you're not consuming any, or starving, or on some weird diet, and you're not getting that glucose, you don't die. You probably know that. People can last quite some time without food. There have been people who have fasted for 40 days, and I know somebody who did that. They fasted for 40 days. I could not believe that. I was just like, my mind going, wow, that's a long time. I think they did have water only or something like that. But I'm not entirely sure. I'll have to ask them. But anyway, so what happens, right? You can make glucose, and you can make it out of amino acids from proteins. Unfortunately, you can convert you can convert glucose to fat. But the body does not have the ability to do the opposite. We can't convert fat to glucose. Again, there's biochemical reasons for that, and that's a big deal because we would love to be able to do that, right? Just convert fat to glucose and then problem solved, particularly if we have excess fat, then great, our brain can go on living and it's not a big deal. But we can't do that. So unfortunately, what our body has to do if you don't have any carbohydrates in your diet, it is going to break down your muscle tissue, right? We can make glucose from amino acids, and amino acids are found in protein. So unfortunately, when people fast or when they starve, they will sacrifice a little bit of muscle mass. And that's one of the things, obviously, you've probably seen pictures of starving people, and their muscles are very, very withered because their body is forcing it to basically take some of those proteins, break them down in amino acids, and amino acids can be converted to glucose. So like I said, I think I forgot to put that in the notes somewhere, but kind of just a side point anyway, I suppose. And like I said, I think we're going to talk about it later on in the semester. Here's just another slide that's talking about excess glucose, right? So, just in terms of what is going on with excess glucose, right? So it says here that fat is left in the bloodstream. So it turns out our body, like our cells, they love glucose. Glucose is the #1 energy source. It's the premium thing. They can take it and boom, they can make energy, and it's wonderful, right? So if you have glucose, why would you burn fat? That's what the cells do. So if you have excess glucose, then the fat is being left in the bloodstream and it's going to be stored in fat tissue, right? The other one, as I mentioned, that excess glucose can be converted into fats, which is stored in fat tissues. So like I said, in small amounts and on a daily basis, we do this all the time and it's not really a big deal. It's kind of the long-term picture of what you're doing, right, in terms of, gaining weight or whatnot. And we're going to talk about calorie deficits and bodies and things like that. And we'll talk a little bit about body image too, right? I don't want to, discourage people from having a little bit of a belly. I think most people get one at some point, whether it's 25 or 45. I think most people, unless you're crazy fit, it's just a matter of time that you might get a little bit of body fat around the edge. So, and then of course, fat cells can also take up glucose. So, like I said, our bodies are really good at doing this, and you got to understand, like, this is not a bad thing overall. In many parts of human history, not getting enough calories was a huge concern for the body. Hello, can somebody confirm that we're back online here? I think I lost my internet for a moment.
Yeah, you're back.
Okay, thank you. Yeah, I'm not sure what was going on there, but we're back. That's good. I was just saying that, in terms of storing fat, this is not a bad thing. Humans for most of history were not necessarily, getting enough calories was a concern. Up until about the 1950s, a big portion of Canada, for example, was they were laborers or farmers. So you're doing work, you're burning calories. In fact, getting enough calories was the concern. Food wasn't in as much abundance. This is kind of a modern problem where we're getting too many, and we're just having amazing access to food. And of course, there's so many delectable things out there that we want to eat, of course. But anyway, a little bit more on this later on when we talk a little bit about weight gain, weight loss. The other thing I think I mentioned before as well is that fat cells it seems that their limit to how much fat they can store is unlimited. So again, we can become very big humans if we do eat a lot of calories. I guess this is just kind of repeating what I said, right? In terms of what the body prefers to do, it's more efficient to store fat than burn fat in a sense, right? And so the body will prefer to consume carbohydrates first and store the other things as fat. Okay, just going to transition here. I'm trying to remember what I was going to say about some of these things. Right, I was going to talk about the Glycemic Index, I believe, here coming up. We want to talk a little bit about sugars and things like that, and we're going to talk about diabetes a little bit too. And probably I'm wondering if we're probably not going to finish this topic today, and I'll talk about that at the end. This is probably our longest topic of the semester about carbohydrates because they're so important. But I did want to talk about the second assignment a little bit too, but I'll save that for the end. So this is saying, what can we do to maintain healthy levels of blood glucose, right? Balanced meals. Consuming complex carbohydrates versus simple sugars, right? That's a big deal. Having regular meals, those kind of things. And again, fiber, right? Fiber slows down digestion and helps you with slow release of all of those things. And sometimes other things in there, right? In terms of, having a little fat in there is good. Fat will also slow digestion, and sometimes it helps release nutrients from various foods and things like that. So again, all goes down to having a healthy diet and healthy habits. So let's talk a little bit about the glycemic index and the glycemic response and the glycemic load. So I have some definitions here, and I'm not going to spend a huge amount of time on it, but if you're diabetic at all, then you might be really familiar with this, right? So the glycemic response really is the effect that something has on your blood sugar levels, right? So are they going to cause those blood sugar levels to increase rapidly or slowly or not at all, kind of thing? And so a lot of foods have been ranked, I guess, or graded on it's a scale of 0 to 100. And so glucose, for example, is 100, right? And white bread is 100. And then so you have all these foods on the scale in terms of how much it raises the blood glucose level within, I think it's 2 hours or something like that, right? You know, it's not exact. Again, depends on the meal you've had. If you mix your meals with, you know, you eat some carrots and then you're eating some, you know, something with some fat in it, that's going to slow down the digestion of the starch and things like that. But it's a start, and it's really useful for diabetics because they're trying to control their blood glucose levels. Maybe even a little more useful than the glycemic index is the glycemic load. So you can see the glycemic load is basically the glycemic index, so you call it GI, right? And then times the number of grams of the food. So that's a bit more accurate, right? You could talk about the glycemic index of carrots, but if you eat one baby carrot, right, compared to, let's say, the glycemic index of a can of soda pop, you know, the quantity is obviously a big deal. I'm not going to get into this a huge amount. Again, it involves a little bit of math and other things, but I'll show you kind of the concept, right? And like I said, it has a lot to do with this is something that diabetics are looking at. You know, they must carefully control their blood glucose and their insulin. And so their whole goal is to try to not build up glucose levels in the blood so that less insulin is needed to maintain the proper blood concentrations. Here's some ideas of some foods. I didn't realize that, I just noticed this now, that a white bagel, I didn't realize you could go over 100. But anyway, just nice little infographic here. I know there's a table in the textbook that's kind of just ugly to look at. I thought this was a little bit better. And to give you an idea, right, anything lower than about 50 or 55 is considered low. Medium is greater than that. High is greater than that, right? So, you know, this is the kind of thing, right, that are looked at. And I'll show you, there's another little infographic, and this one is showing low. So eat these things, high, other things in moderation, kind of thing. But again, you know, most of us can tolerate eating a whole bunch of watermelon, and it's not a big deal. Unless you're diabetic, like I said, you know, we're very good at regulating our blood glucose levels. And we'll talk about diabetes here shortly. I was going to show you this as another way to think about the glycemic index, right? High glycemic index foods, and you're going to get that spike in the blood glucose levels. The lower GI foods, it's gonna get released over time. And so another way to think about it, right, is what was I going to say? For example, again, going to carrots, right? The glycemic load of carrots is much lower than its glycemic index. And I guess I said that already. Again, it has to do with the number of grams. So anyway, I'm not going to go into this any further. I will show you that there's all sorts of these planning guides that diabetics can use. And this one here, I'll be honest, I didn't take a really careful look at it, but my understanding is that the color of the box around each food represents a different scale on the glycemic index, but I'm not entirely sure about that. But again, you know, that's a huge part of diabetes management is you know, managing your diet and carefully thinking about what you're eating and how many grams, because you want to live healthy, right? So let's talk about diabetes. So what is diabetes, right? It basically is, this definition, I don't like it so much because it's actually several diseases, but they're all characterized by elevated blood glucose levels, which usually have something to do with insulin. Either you're not making enough insulin or the insulin is not effective. And so, of course, if insulin is not working right, or you don't have enough of it, you're going to have extra glucose in the blood. And this is going to lead to a variety of different types of symptoms. I was trying to look for some data on this, and I got a couple of numbers here. I found a Stats Canada estimate that 2.3 million Canadians have diabetes. This is, of course, meaning the different types of diabetes, and maybe I'll talk about those here in a moment. So I don't know how many million people we have in Canada, 37, 38 million. I'm just doing the calculation now. Let's say it's 37 million. So that's about 6.2%. But the other big one that Diabetes Canada is claiming is that 1 in 3 Canadians may actually have diabetes or pre-diabetes. And we'll talk about that here shortly, because that is where the big concern is. And 1 in 3, right? So we have, I think we have 30 people in this class, so that's 10 of us. Although again, most of you are probably reasonably young, and often the type 2 diabetes is more, usually a little bit later than you'd say your 20s. I'm assuming most of you are in your 20s or slightly younger or slightly older. There are many types of diabetes. A lot of them are really rare. The kind of 3 big types are type 1, type 2, and gestational diabetes. I'm not really going to talk about gestational diabetes here. It's a type where basically when you're pregnant and suddenly your blood glucose levels start to increase. And usually it's women who have not had any previous history of diabetes. And so something has to be monitored for the health of the woman and health of the baby. And my understanding is in most cases it does go away after the pregnancy, but it might mean that the woman has to take some interventions, dietary and otherwise, during the pregnancy. So it's something that they do look at when you get pregnant. They look at your blood glucose levels to watch for that kind of thing. But I do want to talk about type 1 and type 2 diabetes. Some of the symptoms of diabetes, by the way, there's a whole bunch of them out there. I remember seeing one in the library, and this is kind of one of these funny things, right, where it says signs of diabetes: thirst, and I was really thirsty at the time; fatigue, and I was actually tired that day, right? And of course, you know, and I had to go to the washroom, and so I was just like, holy cow, I've got diabetes. And you know, I mean, so this kind of thing happens all the time when people look at symptoms of diseases. It's very easy to imagine yourself doing this kind of thing. I never got tested or anything, but I'm assuming I'm fine. But you can see some of the other symptoms on there, right? So for example, unintentional weight loss, slow healing wounds, increased appetite, right? Often people who have diabetes or pre-diabetes, they have like intense hunger and thirst and things like that. And if you can have complications, right? We talked about the ketosis, or one of the sort of later stages of ketosis, something called ketoacidosis, where you're getting more acid in the blood from that metabolism, and that can have a lot of side effects. And you know, worst case, sometimes the shock of diabetes can lead to death. Long-term consequences, a whole bunch of really bad things: heart disease, stroke, sometimes minimal circulation in the limbs that can lead to amputation and those kind of things. Damage to other body systems such as the nerves and the eyes. So it's something that you don't want. Thankfully, we do have ways to treat it or prevent it, at least with diet and things like that, and manage it. So I want to talk a little bit about type 1 and type 2 diabetes. You can see there's a chart here that kind of compares them, right? Because they are very different diseases. So type 1 diabetes, by the way, is really an autoimmune disease. Autoimmune disease. So what does that mean? It means the immune system is attacking something of your own body. So this is something that most people who get type 1 diabetes, the onset, meaning the beginning of it, is usually in childhood. I think the typical age is like 7 or 8 or something like that. But there are cases where people have onset even later in life, like up until their 40s, although that's not common. It's usually childhood before the age of 12. It's usually what they say in the literature. But like I said, there are cases where people do get it as they get older. The causes, there's probably a genetic cause and a few others, and I'm not going to get into all that. It's a really, really fascinating kind of thing to look into, but again, it'll probably, I'd spend way too much time on it. But there are links between viruses as well that I find very fascinating. So generally these people, it's a child, and they're not usually obese or anything like that, but the immune system, unfortunately, is now attacking the pancreas. So you can see what is going on here is the pancreas is not making enough insulin, and so that's the problem, right? And you can treat this sometimes with a combination of diet and insulin shots. So these are the people that have to measure their blood glucose, after a meal, and they're going to take a shot of insulin so that they can use the glucose. Without the insulin, think about it, the body cells can't take in glucose. So this was a death sentence for people before insulin was discovered by a Canadian, by the way, Frederick Banting. And that was, I'm not sure when that was, 1930s or something like that. So this can be quite severe in many cases. So, without treatment kind of thing, right? Like I said, a big part of this is insulin and meal planning. So type 2 diabetes. So take a look at this. Not childhood, but adulthood usually. Although we're kind of at a stage where we're starting to see this more increasingly as younger and younger individuals. This used to be kind of a thing that was thought of, over 40 or 50, right? 20, 30 years ago. And now we're starting to see more and more type 2 diabetes in younger people and even kids, which is kind of crazy. And so the biggest indicator, the biggest predictor of type 2 diabetes is this here, body weight, right? And so we'll talk a little bit what's going on there here in a moment. I'm trying to remember if I have a slide or not. So in this case, what is happening is your body is just not responding to insulin the way that it should be. So your pancreas is working just fine, but it's your cells are not, they're just not responding to insulin the way they should be. So extra insulin is probably not going to help you out too much. Although there are some drugs that people can take with type 2 diabetes that might stimulate the pancreas to make excess insulin. Or there's another type of drugs that can actually help the cells to be more responsive and those kind of things. So you can kind of think of type 1 diabetes as not making enough insulin. Type 2 diabetes is being, sometimes we call this insulin resistance. Insulin resistance. So you might hear that term out there. I think I've got some more slides here talking a little bit about treatment and prevention. So maybe I will move on. Just taking a quick look at my notes here. Yeah. So let's talk a little bit about type 2 diabetes and obesity. And I don't think this is fully understood exactly how it works. And there is, with both types of diabetes, a genetic aspect, and there is certainly type 2 diabetes, there is a genetic kind of aspect. Certain families, it's more likely to be in your family if some, and so just something to think about, right? Some people are just going to be a lot more susceptible. And so here's kind of what we think is going on. And this is called the obesity diabetes cycle hypothesis, right? Because it's still something that it's being investigated in terms of what is going on. So the whole idea here is that, as you become obese or heavy or whatever word you want to use, you're storing more fat, right? And as you're storing more fat, you have a bigger body, so you have to produce more insulin because you have more cells. And then there's a certain point where there's just, your cells aren't responding to the insulin the way they should be, right? There's also some part of this hypothesis that has a lot to do with trying to understand what's going on with the blood lipids as well. And it's something that I honestly don't understand as much about it as I'd like to understand as much about it. But it turns out that weight loss can actually reduce the effects of this quite a bit. So a lot of it has to do with, like I said, people producing too much insulin and then the cells not responding appropriately. At least that's my kind of understanding of this whole thing. Hold on a second, I'll come back to this one in a second. Yeah. Okay. So let's just talk a little bit about pre-diabetes for a minute, because you may have heard of this term. And if you are getting a medical or a health checkup or something and they measure your blood glucose levels, they might use that term, that somebody is pre-diabetic. So usually this is referring to people that are on their way to developing type 2 diabetes. And pre-diabetes really, it means that your blood glucose levels are higher than normal. And but they're not high enough to say that you have diabetes, but there may be some damage in your body going on. And so that's really what pre-diabetes is that there's concern there about your blood glucose levels. Now, you may have heard of another term called metabolic syndrome. And I don't think I have this in the notes, but metabolic syndrome and pre-diabetes are sometimes used interchangeably. But if you look up the medical definitions, they're not exactly the same. Metabolic syndrome is kind of I guess you could call it a clustering of, you have like 3 of the following 5 symptoms. And I can't remember what all 5 of them are, but high blood pressure, high blood glucose are 2 of them. Probably high triglycerides, which is fats. But like I said, there's kind of a list of things. If you have any 3 of the following, you have metabolic syndrome. And so you can see they're related, right? And typically, again, obesity is kind of the #1 kind of, risk factor for both diabetes and metabolic syndrome, right? But you could, so you might have metabolic syndrome, and that means that you have pre-diabetes, but you could have pre-diabetes and not metabolic syndrome because maybe you don't have the other risk factors. So anyway, it's not worth getting into all the particulars there, but that's kind of what's going on. You may have heard of both of those things. So according to, like I said, Diabetes Canada, these 2 categories, pre-diabetes and diabetes, are representing apparently 1/3 of all Canadians. I think that's massively high, but I've not done the research in this area to confirm that or not. So what can we do about diabetes, in particular type 2? Type 1 is a little hard to prevent. And my understanding is, unfortunately, for type 1, if you have the right genetics, it's just kind of a matter of time. I could be wrong about that. But type 2 is preventable by lifestyle. And the biggest thing that can be done is weight management. In fact, all of the research shows that weight management is way more important than anything else. People joke about, drinking or having too much ice cream or cake or something like that and saying it elevates your diabetes risk. But it turns out that there's some good research to show that blood glucose levels and consuming lots of sugar, the connection, it may not actually cause type 2 diabetes. It's the obesity part that is the bigger factor. And this is the thing that we're really trying to understand in terms of why that would be the case, because logically it seems if you're eating a bunch of sugar, then your body is going to be maybe releasing a whole bunch of glucose and insulin, right? And insulin resistance is what type 2 diabetes is all about. But the bigger connection for some reason has to do with the weight management. Other parts of the diet that are going to help, and all of these things will probably help with your weight, right? Having the right nutrients, lots of fiber, not as much added sugars and those kind of things. And you can see, again, you've got this massive web of variables trying to tease out, and which is why nutrition research can be, is not as easy as we like it to be. The other one is physical activity. And again, exercise, we're going to talk a little bit of exercise in a couple of units from now, some point after the midterm. But again, physical activity it's going to help with your body, your health overall. And there's good studies to show that people who are physically active do have improved tissue sensitivity to insulin, because you're using your muscles, and muscles, remember, do take up glucose. And so this is an important part of diabetes management. There are other conditions out there. I'm not going to talk about hypoglycemia. Hypoglycemia means it's kind of the opposite of diabetes, where you don't have enough blood glucose. And it's common enough out there. I know a fellow with hypoglycemia, a good friend of mine, and it'll be interesting because halfway through a conversation, he'll be like, just a moment, I can feel my blood glucose going down, and he'll pop a candy. But there's a whole bunch of different causes and cases of hypoglycemia. Some are genetic, some are alcohol abuse and whatnot. I don't actually know much about my friend's condition. I think his is one of these rare genetic things he has. But I'm not going to really say anything more about hypoglycemia. Okay, just doing a time check here. And okay, I think we're in good time. We're going to transition to a couple of other topics here before we finish off for the day. So we're going to talk a little bit more about eating carbohydrates. And one thing that is a good question is, how should I eat around exercise? There's a bit more we're going to say about this later on, and there's a lot of interesting studies on this. One thing that a lot of people kind of get ticked off when I tell them about this is, but there's a lot of good evidence to show that after exercise, women are more likely to eat a lot of calories, and they're hungrier apparently. And I'm not really sure why that is. And of course, it's women who, in many cases, are the ones really trying to lose the weight, unfortunately. But let's talk about eating around exercise and what you can do to kind of benefit yourself a little bit. There's different recommendations around this kind of thing in terms of pre-exercise. I think the textbook says 2 hours before you exercise. And other sources I'm seeing, kind of 30 to 90 minutes. Again, it depends on what you're consuming, right? So usually the recommendation is to make your exercise easier, because of course you don't have to eat before exercise. But let's say you want to go for that really long jog or whatever, right? So you want a little bit of fuel to get you through it. So the recommendation is usually carbohydrate loading, meaning you're eating some complex carbohydrates and starches and things like that, things that digest at a decent speed, so things that are not going to sit in your stomach, so that your stomach is full and while you're exercising. And some people get severe cramps if there's too much protein and fat before a meal, right? So, before exercise. And high fiber is indigestible. So usually reasonably digestible things is what you're looking at, to give you a little bit of energy to get through the exercise and to power your workout kind of thing. What about during the exercise? Again, it depends on how long you're exercising, right? If you look at me, like when I typically go to the gym, I would say my average workout time is 20 to 30 minutes. So I don't need food while I'm working out. A little bit of water. And speaking of the water, it's usually best to sip it, not guzzle it. Notice it says here, in most cases, avoid the sports drinks. They're full of sugar, or at least the normal ones are. If you get the sugar-free ones, they are, but you don't need them, right? In most cases. And we'll talk about those sports drinks in a minute, and we'll talk about them in another unit as well. But the recommendations is you have maybe a cup of water every 15 minutes. Again, it kind of depends on how vigorous it is, how hot it is. If you're jogging outside in the summer, you're probably going to sweat a lot more, all those kind of things. So listen to your body in terms of how thirsty you are. But sip a little bit of water, your workout will go a lot better. We'll talk a little bit about the sports drinks here in a moment, but some people do consume food while they're exercising. So usually you're talking about carbohydrates that would be digesting quickly, right? Things are not going to sit around in your gut. After exercise, the recommendation, this is when you eat things with protein, right? So your body is ready to start building, let's say, some muscle mass and repairing any, no matter how light your workout, there's always a little bit of repair to go on. So the recommendation actually is that you eat something with a little bit of protein, a little bit of carbs, and a little bit of fat. So you're getting a little bit of everything in there. And, one of the highest recommended post-exercise recovery foods, believe it or not, is chocolate milk. So think about it. Chocolate milk has protein in it. It has some carbohydrates that you're going to get in the system really quickly, a little bit of sugar in it. It contains fat, and it's delicious, and often you're thirsty. Like I said, there's a lot of recommendations for these kind of foods. I have like a little graphic here showing some ideas. So the pre-exercise, you can see a sweet potato, a bagel, or an apple. Sorry if the images are a little bit small. So things like that, right? Fruits and things like that. During exercise, the water. And the recommendation with sports drinks or sports gels is you avoid them basically entirely, unless you're working out more than an hour, or you're doing that multi-day training, you're working 8 days straight or so, working out 8 days straight or something like that. Or if it's particularly hot and vigorous. So Gatorade, for example, and Powerade and those kind of things are really popular with team sports, soccer and football, and usually it's the kind of thing that you know, in the first half of a game, right? Like you don't need it for a while, right? And so often a lot of sports teams, they're recommending that they drink water for the first 30 to 40 minutes before taking in the sports drinks. Again, it depends how much you're sweating and losing electrolytes and things like that. But for the most part, most of us, we're just better off avoiding them because it's a bunch of extra added sugar that we don't need. Now that again, I'm sure some of these have all sorts of other things in them that they're trying to market them, you know, vitamins and whatnot, and that's how they're trying to make it a little healthier. But you know, water is good food. You can see some ideas of some post workout meals. So you can see this one here. This plate has a balance of protein and vegetables and starch. Not really having any fat in that meal, but a little bit of fat is not a bad idea. You know, fat is an essential part of our diet, and we're going to talk about fat in I think not the next unit, but the one after. So we'll talk a little bit about fats. So I think we've kind of talked about some of this already, but I just kind of want to talk about carbohydrates in foods in terms of where we're getting them from, right? And so going way back to the very beginning of this unit, we talked about the recommendations are that people get around 50% of their calories from carbohydrates, right? Again, depending on your age and your lifestyle and those kind of things, the recommendation can go up or down. And so let's talk about a little bit about some of the foods. Whole grain foods, of course, are good. They usually have fiber in them and things like that. And there's some examples of some whole grain foods. And again, the nutrient content of these things can vary dramatically. So oats, for example, has a lot of fiber in it. So tends to be a lot better for you than, let's say, popcorn, which really doesn't have quite as many nutrients in it as we'd like, even if it's delicious. And of course, you know, what are you putting on these things? Or what are you spreading on your bread? Are you sprinkling a whole bunch of sugar on your oats? Or are you putting strawberries in there? What about the popcorn? Are you adding butter and things like that? Those are all questions that can be asked. Vegetables, of course, are another thing here. So you can see one of the other things, right, is that can be rich in fiber, which is true for a lot of whole grain foods. Fruits, on the other hand, are kind of and vegetables are kind of a mixed bag because there's such a variety of these things, and they really have a high variety in terms of the nutrient contents. You know, some of these vegetables are very fibrous, right? So celery, for example, is very, very, very fibrous. Carrots, much less so. You know, and potatoes even less so unless you're eating the skin, right? Starchy vegetables have a lot of complex carbohydrates. Some of them don't have quite as many. Again, you know, celery doesn't have a lot of starch in it, not a lot of sugar in it either. So it's not a bad thing. It's kind of high in fiber, right? Fruits, again, even more variety in terms of those kind of things. And one of the big things about fruits is, of course, some fruits are full of sugar and some are not. Usually, though, when we're talking about our intake of sugars, we're usually not so concerned about fruits because in terms of the amount of sugar in them compared to, let's say, refined, purified sugars, you're still not getting a ton. But again, it depends on the fruit. Strawberries are very rich in fructose, for example, and you know, I'll confess, I've probably eaten an entire carton of strawberries at least once or twice in my life, and that's a lot of sugar to digest. Of course, doing the math, I'm not sure how much that is compared to a can of pop, but you know, something to think about, right? So what about protein-based foods? We don't get a lot of carbohydrates there usually. Particularly meats, almost no carbohydrates. Meats are mostly protein and fat, but other protein-based foods, any of the plant things are going to have complex carbohydrates in there. So we're talking about, you know, nuts and lentils and beans being kind of the big things that have a decent amount of protein, and the amount of starch and fiber kind of varies depending on what you're looking at. So again, you know, this is something to think about if you're trying to balance your diet a little bit about and making sure you do have some carbohydrates in your diet. Milk is another one that's worth talking about because, of course, milk is does have the lactose in there. And we talked about milk kind of being one of the exceptions of being an animal product that has sugar in it. And of course, the lactose is the sugar there. So generally, the recommendations with milk is they're telling people, go for the low fat options. If you can't have milk, there are other options out there, such as the soy beverages that are fortified with calcium and things like that. So, again, calcium, we'll talk about that. We have a whole unit on water and minerals, and we'll kind of get into some of those nutrients a bit more. Okay, so again, time check here. I do want to talk a lot about sugars and artificial sugars and those kind of things. And let me just take a peek ahead here for a second. So maybe I'll just talk about sugars for a minute, and I'll probably end here. I do want to talk about assignment 2 for a moment, but we'll probably finish early today because it's kind of not worth it getting into all the stuff on sugars here without cutting it short. So it's just kind of worth it to talk about it all together. Like I said, lots to say about sugars in terms of, do sugars cause obesity or hyperactivity, a little bit of those kind of things, and artificial sugars and whatnot. So a couple of quick things to say about sugars. The recommendation is that we get no more than 10% of our calories from sugar. And you take a look at this, I've got a little infographic here. I'll come back to that in a second. Where's my infographic? So this is the infographic here. So in terms of the number of teaspoons, right? Kind of the recommendations for the average man, maybe about 9 teaspoons, and the average woman about 6 teaspoons. And so I wanted to show you this. Oh, where's my graph? Sorry, this is all stuff we're going to talk about next day. Really exciting. So there's my graph there. So this is kind of showing, the trend in Canada. So there's some good news. It seems to be going down. But you can see in terms of the amount of energy per day, we're a little higher than 10%. We used to be quite a bit higher, maybe 13%. Now we're down to 11%. So it looks like there's a good trend there. But the reality is that many Canadians have double or triple that amount, that recommended amount. So this is something we're going to talk about next day. We're going to talk a little bit about naturally and added sugars. And kind of the point I wanted to make here today is that, don't get caught up in that. 100% fruit juice, no added sugar doesn't mean anything. Our body handles sugars the same, whether you get sucrose from a natural source or whether it's added separately, it still is extra sugar. The last thing I'll say is for today about this is that I actually went grocery shopping yesterday, and I wish I'd taken some pictures. This is just off the top of my head, remembering what I saw. I remember going down the aisles, and particularly in the baking goods aisle where you can buy sugar. And I was a little blown away about all the products that were there. Some of them I had never seen before in the grocery store because I had not been looking for them. For example, this agave syrup. But all of these things here, right? When you start looking at the labels, you start to see all these things about it's natural, it's healthier than normal sugar, it's this, it's that, fortified with something. And the reality is all of these products here are mostly sucrose, with the exception of the agave sugar syrup, which is mostly fructose. And your body doesn't care. It's the same sucrose that you get from table sugar. So don't be deceived by all the marketing. There might be a little more fiber in brown cane sugar, but really, are you trying to get your fiber from eating brown cane sugar? There might be something else in honey that's going to prevent cancer, but really, are you going to try to prevent cancer by eating a lot of honey? Anyway, just something to think about on that, and we're going to address here next day. But I'm going to stop there because I don't want to get into all the sugar stuff and have to break it up. So I'll probably say some of these things again next day. It's certainly worth talking a lot about sugar. I do want to just say a couple of things about assignment number 2. My plan was to hand it out today, and you can see I'm not handing it out. I just getting behind in all my work. So I'm hoping on Friday, my plan is to hand that out. You're still going to have like a month to do it. So you're not going to be crunched for time or anything like that. I know that I am not going to have assignment 1 graded by Friday, but I will have started to look at assignment. And I know some people did their infographics on some of the alternate sweeteners, the artificial sweeteners. And so I might show some of those infographics. If you really don't want me to show the class your infographic, I'll probably take the names off anyway. Just let me know, okay? But I might show some of those infographics. I know I looked at some of them already, and some of them are very nice to look at, and give a little bit of information about artificial sweeteners and things like that. Okay. Anyway, I feel like I've been going on for a while. I probably loaded your brains with all sorts of information again, and we'll pick this up on Friday. Talk more about sugar. We'll talk more about assignment 2, and in the meantime, I hope you have a wonderful day.